Hello and welcome back to another video. This is an IGCSE Physics video for some exam tips or revision. Let's begin. Now, we will start with electricity. So, in electricity, we can have two types of circuit. We can have a series circuit or a parallel circuit. We can even have a combination circuit where some part is series and some part of the circuit is parallel, and you're going to apply appropriate rules according to whether series or parallel. Remember, voltage in series, voltage is added, while in parallel, voltage remains same. In series, the current is same, while the current is added in parallel. Okay. Finally, for resistance, to find the total resistance in series, add them, and to find the total resistance in parallel, it's going to be the reciprocal of total resistance equals to 1 over R1 plus 1 over R2. And then when you want to find RT, you're going to make RT as a subject and solve for RT. Okay. Otherwise, sometimes if you only have two resistors, you can even apply this formula, R1 times R2. But remember, this is only for two resistors only. If you have three resistors or more, you have to use this equation. This would be plus 1 by R3 and so on. It just goes on. Now, remember, we have different types of resistors in electricity. Remember, this thing is a normal resistor. This is not a resistor. This one is a fuse. This is a resistor. And finally, we have a variable resistor here. Variable resistor is something that does not have a fixed resistance. You can change its resistance for variable resistor. This one is fixed. Now, there are other types of resistors which are LDR. Remember, L stands for light, D depends for dependent, and R stands for resistance. A resistor, light dependent resistor. Just as the name suggests, the resistance depends on the light. When light increases, resistance decreases. So that means they are not directly proportional. They're inversely proportional. The symbol is this. It's a regular resistor symbol, and then it has a light coming on it. On the other hand, we also have another resistor, which is called a thermistor. It is dependent on the temperature. We can have positive or negative temperature coefficient resistors. So for positive, they are directly proportional. When the temperature increases, resistance also increases. For the other one, for NTC, it's opposite. When temperature increases, resistance decreases. This is the symbol for a thermistor. Now moving on. So this is a simple example where you have a power supply, and then you have three lamps. One lamp is connected in series, whereas the other two lamps, L2 and L3, are connected in parallel. So let's compare the voltages, current, and resistance in each of these lamps. Total voltage equals to V of lamp 1 plus V of lamp 2, and lamp 3 is same. So we can just write L2. This is the total voltage. Alright, let's try to identify the ratio between L2 and L3. So L2 and L3, remember, in parallel the voltage is same, so it's 1 to 1 because voltage is going to be same in parallel. Next, let's write down the equation for total current. So remember, in total current, I total equals to IL1. How? The current that is coming from the battery source is going to be equal to the current that's coming out of L1. So I total equals to L1. This equals to IL2 plus IL3. That means this current L1 is going to be divided into L2 and L3. So it becomes half. It divides into equal halves, and when you add them, L2 and L3 add up, you get the total current or the current that was in L1. Let's try to write the ratio between IL1 and IL2. The current here and current here, that is going to be 1 to half. Why? Because this current was divided into two parts. Remember, all the lamps are identical, so their resistance is same. Like L1 will get all the current, and then L2 and L3 will get their current will be shared equally. Okay, so L1 is 1, L2 is half. This can be written as 2 to 1. Next, let's write the total resistance. So total resistance is equals to the resistance that was in L1, resistance here, plus the resistance of this parallel circuit. So that is going to be L2 times L3 divided by L2 plus L3. Remember, because these are identical lamps, the resistance in each individual lamp is same. Okay, now if asked to write the ratio between RL1, that means the resistance for lamp 1, to the resistance of this parallel circuit, that is going to be RL1 is going to be 1 to what is the resistance of this parallel, and let's say that is 1 multiplied by 1 divided by 1 plus 1, that makes it 1 over 2. So we can write this as 2 to 1. That's the ratio between two. Now let's try to, we have another simple question. We have our voltage, we have a circuit here. Find EMF and potential difference. Remember, EMF is the voltage across the battery, so that is 4.5 volts. What about potential difference? The form across diode, V equals to EMF minus IR, current times resistance of the circuit. So this is going to be EMF is 4.5 minus current, which is 0.02, multiplied by the resistance of the circuit, which is 60. These values are given here. We got 3.3 volts. Now we can move on. First of all, let's say if they ask you for some base quantity, for some physical quantities, you can mention any of these. If asked for SI unit, remember kilogram for mass, meter for length, second for time, A for current, ampere for current, Kelvin for temperature, and candela for luminosity. Now remember, if we have to convert, speed equals to distance over time. What is the formula for distance? That is a meter over second. Let's say if they ask you to convert into kilometer per hour, convert meter into kilometer. So let's say this was 2 meter per second. This is going to be small to big is divide. So divide this by 1000. Second to hour is per second to minute is divide by 60. Minute to hour is divide by 60. You will get your answer in kilometer per hour. If you were asked to convert it back, you can multiply. So this is how you can convert. Now remember scalar and a vector quantity. A scalar has magnitude, vector has magnitude as well as direction. If asked for to identify, remember speed, time, mass, and energy, they are scalar. On the other hand, weight, acceleration, velocity, momentum, electric field strength, and gravitational field strength, all of these are vector quantities. Gravitational field strength of the earth, gravitational field strength from the earth points towards the earth. Electric field strength, if it's positive, it's outwards. If it's negative, it's inwards. Now these are some important values that you should know. So speed of light in air, in vacuum, whatever, is going to be 3 times 10 power 8 meter per second. Speed of sound in air, water, and concrete and steel. So in gases, the speed is less. In water, it increases, and solid is the highest. So in air, the speed is 330 meter per second. In water, it's 1400 meter per second. In concrete, it's 5000 meter per second, and in steel, the speed is 6000 meter per second. Next, remember the audible frequency range is from 20 Hz to 20 kilohertz. It could decrease as we age. 1 light year equals to 9.5 times 10 power 15 meters. Finally, the current estimate for Hubble constant equals to 2.2 times 10 power negative 18 per second, s minus 1. Now here are some estimates that you should know. So what is the density for water? Density of water is 1000 kilogram per meter cube. Density for air is 1.2 kilogram per meter cube. Remember, okay, if you're asked to convert 1000 kilogram per meter cube into gram per centimeter cube. First, convert your kilogram into grams. Convert meter to centimeter. That is going to be big to small multiply by 100. And then since you have power 3, you're going to write power 3 here as well. Answer in gram per centimeter cube. Now, What happens to density as with temperature? Always remember, generally when temperature rises, density reduces. Remember the equation for density? Density equals to mass per volume. If the volume is increasing, density will decrease. So when temperature increases, volume also increases because they have expanded and they occupy more space. Therefore, density reduces. This also explains convection. When you have a beaker and you heat it, this is filled with a liquid, okay? So here when you heat it, this becomes hot, and temperature rises, so density reduces. Density decreases, so it goes up. Now the colder particles are at the top, low temperature, so density is higher. Therefore, higher dense particles will go down. So this is called as the convection current, and this explains how that happens. Anyways, now we can move on to another topic, which is graphs. Graphs are very easy, but a lot of people can make a lot of mistakes there. Always remember that when you are plotting your graph, you are using a sharp pencil. Secondly, always use a pencil, not a pen. Make sure to label your axis and look at the units of axis. Sometimes if you are supposed to make calculations with your graph, you might need to convert them. For example, if this was kilometer per second and they ask you the answer in meter per second, you will need to convert your distance, right? So make sure of that, and always make sure that your graph covers at least more than half of the axis. If it's too small, you can lose your mark. Alright, so now we have a distance time graph. X-axis represent time, y-axis represent distance. Now what does the gradient of distance time graph represent? It's the speed. Now let's identify what's happening in each of these regions. So from A to B, you can see that there is a slope, a positive gradient, so it means we have constant speed. Now what about region B to C? This is a flat line, the gradient is 0. This tells us that the object is stationary. What about region C to D? So here we do have a slope, it is increasing, but we have a curve. So the curve means that the speed is changing. Now when speed is changing, this is called as acceleration or deceleration. If the speed is increasing, it's acceleration. If the speed is reducing, that's deceleration. If you notice, the graph is becoming more and more steeper, so the gradient is increasing. Therefore, you can say that the object is accelerating. Finally, we have DE. DE is also a slope. Now the object is also moving at a constant speed. Object is moving back to the starting point. Object moving in constant speed back to starting point. In region A to B, it's moving away from the starting point. If you're asked if the speed is higher between region A to B or region D to E, we can say it's going to be D to E. Why? Because the graph is more steeper. The gradient is higher, so it means more speed compared to A to B. If you're asked to find the speed of a curve, what do? You're supposed to draw a tangent. If you're supposed to find the speed at this point, for example, that's called the instantaneous speed. Just take a ruler and draw a line at that point. And then you're supposed to find the gradient of this tangent. The gradient of this tangent will give you the speed at this instant. That is called as instantaneous speed. Now let's move on to the next graph, which is speed time graph. Remember, the gradient of a speed time graph represents acceleration. Now let's try to identify what's happening in each of these regions. So first of all, we have time on x-axis and speed on y-axis. In region A to B, we have a straight line. When we have a straight line, this has a slope. Positive slope means that the speed is increasing, so we have constant acceleration. In the next region, we have a curve. We don't have a constant acceleration. The acceleration is changing. Why? Because the gradient is changing, and as you can see, the graph is becoming less and less steeper, so we can say reducing acceleration. Then region C to D, we have constant speed. Why? Because the speed remains same. If it was 30, it would remain 30. And then finally, from region D to E, we can say we have a negative slope, and it's a straight line, so this is constant deceleration. Now, if we have another graph, this is a distance time graph, and we have curves. Remember, whenever we have a curve, this curve represents that the speed is changing. Now, when speed is changing, it could either increase, representing acceleration, or the speed could decrease, representing deceleration. So let's identify the region of acceleration and deceleration. So we can see here the curve is becoming steeper and steeper until this region. So this is going to be, let's call this region B, region A, and region C. I think it would be given to you in your exam paper. On the other hand, B to C, the graph is becoming less and less steeper, so the speed is reducing, this region is decelerating. Now let's quickly review the concept of terminal velocity, and then we will see the graphs for it. So remember, initially when an object is falling down, the main force that's acting on the object is the weight. So we do have a resultant force which is acting downward. After some time, as it falls, the air resistance increases. Air resistance or drag, it's in the opposite direction to the weight. So this is going to affect it. Now resultant force reduces. The resultant force will be weight minus drag. Resultant force reduces. Now remember, when we have resultant force, we have acceleration. So here the object was experiencing constant acceleration as well. Over time, as the resultant force reduces, the acceleration also reduces. Finally, it reaches a point where the weight equals to the value of air resistance. Now the resultant force becomes as less as 0. It's gone. That means acceleration is also 0. When the acceleration is 0, it reaches a constant speed. This constant speed is called as terminal velocity. Now terminal velocity depends on certain factors. It depends on the mass of the object. If the mass is high, the terminal velocity is also going to be high. On the other hand, it also depends on surface area. If you have a greater surface area, for example, if you compare a paper with a ball, if you throw the ball, it accelerates and reaches down quickly. Whereas if you throw paper, it goes down slowly and slowly. Why? Because it reached terminal velocity. So if you have more surface area, the terminal velocity is going to be low. Now let's look at this example. So identify the graph of a tennis ball and a beach ball that had reached terminal velocity. So basically a small dense object, such as a tennis ball, will have this graph for a small dense object. It has a high terminal velocity compared to the beach ball, which is light and not that much dense, and it falls a greater distance before reaching terminal velocity. On the other hand, beach ball is light. It has greater surface area, and its terminal velocity is low, and it reaches much quicker. For example, here it reached at this time. Here it reached at this time. Moving on to energy changes. These are just some of the examples of energy changes. A turbine can convert kinetic energy to electrical energy, where generators is the opposite. The electrical energy is converted to kinetic energy. What about stretching a rubber band? And when the rubber band is stretched, it has elastic potential energy. When you release the band, the elastic potential energy is converted into kinetic energy as you leave the rubber band. Now we have something else. This is evaporation versus boiling. Which of them happens only at a fixed temperature? That is going to be boiling. Why? Because the substances have a specific boiling point. For example, for water is 100 degrees Celsius. Evaporation, on the other hand, can happen at any temperature. For example, if you dry your clothes out in the air, the water will evaporate and the water will be gone. Even though it didn't reach up to 100 degrees, the water evaporated and it was not there. Now, no bubbles seen. Is it evaporation versus boiling? It's going to be Evaporation, because you don't see bubbles, you see bubbles when you're boiling. For example, when you're boiling water. Something that happens only at the surface, that's evaporation, whereas boiling boils the whole liquid. Now it requires a specific heat source, that is boiling. What are some factors that can affect evaporation? The temperature. If the temperature is high, evaporation will be faster. Surface area. If you have a greater surface area, for example, if whenever you dry your clothes, you make sure that your clothes are open and they are exposed, so the surface area is greater. On the other hand, if you just like crumble up your clothes, wet clothes, it's not gonna dry soon, right? So surface area matters. Secondly, wind or drought. If there is a wind outside, the clothes will dry up much quicker than, for example, if there was a humid weather. Humidity will reduce, and wind and drought is going to increase the rate of evaporation. The topics of lenses. There are two types of lenses. We can either have converging lens or we have diverging lens. Just as the name suggests, converging is going to converge the light rays, something like this, at the focal point. On the other hand, diverging is going to diverge them. Now in a lens, you have an optical center. This is the center of the lens. You also have principal axis, this one. This is the line which is perpendicular to the lens. This is your lens and it passes straight through the optical center. You also have principal focus. This is the point on the principal axis at which the refracted beam of light meet. This one. And now let's have a look at the rules when you have your objects. So first, if your object is beyond 2f, that means if your object is here, the image is going to be real, the size is going to be smaller, and it's going to be inverted, and your image location is going to be closer to lens. Secondly, if your object is between f and 2f, that means if it's here, again the image would be real and inverted, but the size would be bigger than the object, and the image location is going to be further away from the lens. Now, what if your object is exactly on 2f over here? The image would again be real and inverted, but since it's on 2f, the image will also be on 2f, and it will have the same size and equal distance as the object. Finally, if your object is here, between your lens and the principal focus, it is going to be virtual. The size is going to be bigger, and you will not have an inverted image. It will be upright. Finally, the image would be behind the lens. And if you have your image here, to look at the object, you have to keep your eyes here. You might be asked to label where do you keep your eyes. An example of this type of lens is magnifying glass. Next topic, we'll discuss the internal energy of a substance. So when there's a substance, solid, liquid, or gas, they either have their molecules have kinetic energy as well as potential energy. Now, when you're heating a substance, and let's say that the temperature is rising from 20 degrees to 30 degrees, so you can say that the temperature is increasing, therefore kinetic energy is increasing at this point. Now we have another situation where we have ice and that is melting. If you notice, the temperature is not going to increase, the temperature remains same, but the heat is still being absorbed. Why? Where is that heat going? That heat is going to change the state, so the potential energy is changing. How is the potential energy changing? Now when ice is melting, the molecules are going to move farther away. Now looking at this graph, can you identify different stages? We can see that the temperature is increasing. As the temperature since the temperature is increasing, the state is not changing. We can say this is solid. Then as it reaches 0, it remains constant for some time, and then it changes again. So the state changed at this point. This is liquid, but this change of state is called as a melting. After it has become a liquid, and when it reaches 100 degrees, it becomes constant again. So now it's boiling, and then beyond that it's gas. Solid to liquid is melting. Liquid to gas is boiling. What about gas to liquid? Gas to liquid is called as condensation, and then liquid to solid is called as freezing. Now, Let's discuss about reflection, refraction, and diffraction. Remember, this thing can be used to represent reflection. Reflection happens on a shiny surface, falls there, and it falls back at the same angle. This could be your normal. Angle of incidence will equal the angle of reflection. Now here we have two examples for refraction. So this happens when light waves or waves moves from one medium to another medium. Now, when can you identify which one is rarer and which one is denser? If you see here, this is your angle of incidence, and this is the angle of refraction, always between your line and the normal. So angle of incidence is smaller, and then it's moving away, so it's going from a denser to a rarer medium. Denser medium, speed is low, and rarer medium, speed is higher. For the second one, let's draw our normal as well. Now you can see angle of incidence is greater and this one is smaller, so the speed is reducing as it moves from the rarer medium to denser medium. Speed is reducing as well as the wavelength reduces as well. Now let's see what happens in each of these cases. So when you have a reflection or when you have diffraction, your speed, frequency, and wavelength, both of them remain same. They are both same. What about refraction? The frequency remains same, whereas speed and wavelength changes. Speed and wavelength changes whether it depends on from which medium they are moving to. In diffraction, only the shape changes, whereas in reflection, the direction changes. Now we have some wavefronts. So remember, wavefronts are always drawn perpendicular. That means if this was your line which is being reflected, your wavefront is going to be something like this, drawn perpendicular. If you're asked to show reflection of wavefronts, you can see this. Wavefronts are hitting and then they are being reflected back. Now we have refraction. For example, let's say we have deep water and we have shallow water. So in shallow water, basically the speed is low, and so is wavelength. Wavelength is also small. Whereas in deep water, we have higher speed and we have more wavelength. So this is how your wavefronts will look like.